All right, here's a walkthrough of the last problem. This is definitely the hardest one. When problems involve rate, in this case, we have some speed of a person involved. That's always tricky because that's sort of a hard to picture quantity. The relationship that we are going to take advantage of, in this problem is the relationship between distance, speed, and time. So we think of it as distance equals rate times time. So rate is your speed. So this is not that different from just saying, if you go 50 miles an hour for 2 hours, you've gone 100 miles. So you multiply your speed times how long you traveled, and that tells you how far you traveled. So that's the underlying relationship here. Now, the part of the problem is that football yard lines are numbered weird, right? They go up and then they go down again. So the yard line itself really can't be the issue. The question is about the distance traveled. So if we know that that the tight end made it 40 yards before he was tackled, then we can figure out what yard line that was at. But let's make our quantity that we're studying be the distance the tight end ran, not what yard line they were on, since that's weird. So I'll follow my my suggestion of saying, well, this is a complicated problem, so let me just guess an answer, and then we'll check carefully to see if this guess is right. And I think in the process of doing that, we'll see exactly how to set up the general problem. So let's guess that the tight end gets 30 yards before being tackled. Okay, so that would put him, if you look, that would put him at the 50, I guess. But again, trying to figure out how to think about it in terms of yard line is crazy. So so let's say the tight end gets to the goes 30 yards before being tackled. So that means I'm going to try to leave this over here. I don't know if I'll be able to. Might have to do this on another page too. The defensive back starts 5 yards behind him, right? The defensive back is starting off 5 yards further back. So the defensive back has to go 35 yards in that same time. So that's what's going on here, is that if the tight end is caught after 30 yards, that means that the defensive back was able to run 35 yards in the same amount of time it took the tight end to run 30 yards. So is that right? I mean, is that what actually happens with the speeds that are given here? Well, so we have to think about distance, rate, and time. Rate will be a speed. So in this case, it'll be in yards per second, since we're told how many yards each of them run in a certain number of seconds. So the tight end's speed, I'll continue to call it rate, just because that's what we normally use, how we usually describe that. The tight end's rate is 100 over 12 yards per second. So we just divide how far you go, divided by how long it takes you, and that's your speed. So that could be simplified. That's like 25 over 3, I guess, whatever. But there's no great advantage to worrying about the fractions at this point. The defensive back's rate is 100 over 10 yards per second. So that does simplify nicely. That's just 10 yards per second. So the defensive back can cover 10 yards every second. And the tight end's a little bit slower than that. And so the distance the tight end covers, the 30 yards, is equal to the tight end's speed times the time that he's running. And I'm just going to write time in there because notice that's not given in the problem. And that's really the trickiest thing about this problem, I think, is that it seems like you may not have enough information because we don't know what that time is. So that's the tight end following this distance equals rate times time equation. Second would be the defensive back. So the defensive back goes 35 yards. His speed is 100 over 10, which I'll just keep writing that way so I'll remind myself where it came from, times the time. And so so if I'm trying to check that if this is right or not, I don't know because I don't know what the time is. But notice that the key is that if the defensive back catches up to the tight end and tackles him, that means that the time in both of these equations is the same. So the time in both of these equations is the same. And so that's sort of the big moment for this problem in order to be able to check that it's right. The first equation I could solve for time. In other words, I can multiply both sides by the reciprocal of 100/12ths, multiply both sides by the reciprocal of this equation, and I'll have time equals whatever it is. Do the same thing here, I'll have time equals whatever it is. And if I do that with both of them, the time has to be the same. So those two things should be equal to each other. So let me do that. I don't think I have enough room to fit it on next to it, but I'll write it down here. So we call this 1 and this 2. So equation 1, if I multiply both sides by 12 100ths, I'll have 12 100ths times 30 is the time that it takes before the tight end is tackled. Equation 2 is 10 100ths times 35 is the time that it takes the defensive back before that happens. And so the question is, are these equal? 12 over 100 times 30 equal 10 over 100 times 35. So is that true? So if you check, you'll find that on the left-hand side, that's 360 over 100, and on the right side, that's 350 over 100. So those are not equal. You can see why I didn't simplify the fractions now. The details of the fraction really don't matter. It's easy to check that those are equal. It's easier to check they're equal by leaving the 100 in there without it being simplified. And so the answer is no. Okay, so that's not right. So the original guess of 30 yards for the tight end and 35 yards for the defensive back is not right, because it takes the tight end this much time to run 30 yards, and it takes the defensive back this much time to run 35 yards. And since this number is a little bit more than this number, that means that the tight end's actually going to get. The defensive back is actually going to get to cover that 35 yards at a less time than the tight end is getting to his 30 yards. So that's not right, but the whole point about our guessing is that it should allow us to go back and revise this and use variables instead of numbers. So I'm going to do that. I'm going to try to do it by just marking up my example with a different color. So I'm going to use blue. So this is my guess, 30 yards. So I'm going to make that X. I'm going to say the tight end gets X yards before being tackled. That means the defensive back has gone X plus 5 yards. Right? The defensive back starts 5 yards further back. So at this moment that the tight end's being tackled, the defensive back has to have covered exactly 5 more yards because he started 5 yards back. And so that means these things are the same. Right? That's just the speeds that these guys run. That's not has nothing to do with where they start or where they end. This is X. This is X plus 5. And so the rest of this equation is still exactly the same. Right? The distance traveled is the speed times the time it takes. And that key idea that the time in both cases has to be equal, that's what you mean by the defensive back catching the tight end, is that at the same time that the tight end has run X yards, the defensive back has run X plus 5 yards. So that part's still the same. So this idea of solving these two equations that I have here for time and then seeing if they're equal to each other should be the same. So I go on. Again, here, this 30 is really X. This 35 is X plus 5. And so the equation here is this. So the equation that I end up with is 12 over 100 times X equal to 10 over 100 times x plus 5. 12 over 100 times x equals 10 over 100 x plus 5. So that's the equation. We found that when x was 30, this wasn't true. But now that we have it written in terms of x, we can actually solve for x. So this would be 12 100ths x equals 10 100ths x plus 50 100ths. I guess I could have just multiplied by 100, huh? Yeah, that'd probably been smart. Anyway, I'm into it now. So that's distributing this, this 10 100ths through the parentheses. And notice that I'm purposely not simplifying these fractions just because to do a fraction work, I need to have common denominators anyway. So it doesn't make any sense for me to have simplified each fraction down to different denominators and now have to change them back to common denominators. So since they had a common denominator of 100 originally, I would just left them like that through the whole problem. And we can simplify it at the end. So if I subtract the 10 100ths x from both sides, I'll have 2 100ths x equals 50 over 100. Now it would make sense to multiply both sides by 100. That'll leave me with 2x equals 50. So times 100. Probably not the best symbol for times. And so x is 25. So remember, the x was how far did the tight end go before he got caught. And so 25 yards. Remember, he started at the 20-yard line, and so 25 yards later, he'll be at the 45-yard line. That's the 45-yard line before going across the 50 and having the numbers go down again, right? But that's where the tackle will occur.